in the context of uncertainty principle, you have studied position and momentum as the conjugate variables. Here in this discussion, I am going to discuss about energy and time as the conjugate variables. There are so many conjugate variables in the study of quantum mechanics. You get all those things, such as spins are there, spin along x-axis and spin along y-axis. These two are also conjugate variables. Again, electric field and magnetic field are there. Those are also conjugate variables. Similarly, energy and time, both are conjugate variables. You will get this thing in the study of uncertainty principle, Heisenberg's uncertainty principle. Okay, you know that the principle is like this. There is a limitation to the precision by which a pair of particles can be measured. Pair of particles. This pair of particles is called conjugate variables. Normally, in the discussion of uncertainty principle, you have studied only position and momentum as an example. But here, energy and time is also a conjugate variable. In the study of classical physics, you know that time and energy both are independent and separate variables. They are not dependent on each other. But in the study of quantum mechanics, you will find that energy and time are not separate and independent variables. They are dependent on each other, means they are linked. The precision with which one tries to measure the energy of a quantum system, if precision in the measurement is more, then you will get less accurate results for the time. Time is here what? Time is the time at which the measurement of energy was made. You will get inaccurate result for time. Okay, and vice versa. So here what you can see, that time is not an independent variable. As in classical physics you have studied that time is an independent variable. But here time is not independent variable, they are linked together, time and energy. So, but the problem is that there is no direct experimental verification of these two variables. But indirect measurements are there, and indirectly physicists have proved that yes, this is a conjugate variable and they are dependent on each other, both energy and time. Okay, once again I want to repeat the same thing, that there are so many conjugate variables. If you study uncertainty principle mathematically, you know that for momentum and position, and momentum, the mathematical relation is expressed as delta x into delta p is greater than or equal to h line by 2 or h bar by 2, where h bar or h line is a reduced Planck's constant, which is equal to 1.055 into 10 to the minus 34 joule seconds. That is reduced Planck's constant. Okay. And delta x into delta p. Delta x is the uncertainty in position and delta p is the uncertainty in momentum. Similarly, the same relation holds good for energy and time also. And this is expressed as delta E, T for energy, into delta T, T for time. Okay, so delta E into delta T is greater than or equal to h line by 2, where delta E is the uncertainty in energy and delta T is the uncertainty in time. Okay, so mathematically this can be expressed the same way. There, in that case, for position and momentum, it was delta x into delta p, and in case of energy and time, it is delta E into delta t. So these are conjugate variables, they are dependent on each other. There is no direct verification of these conjugate variables, but there are indirect evidences available. Okay, if you study in depth this subject quantum mechanics, then you will find that there is indirect evidences are available. Okay, so this was all about uncertainty principle, Heisenberg's uncertainty principle in the context of energy and time as the conjugate variables. Okay, so this is the end of this video. Thank you for watching this video.